Dear students, myself Sudhir sir, PGT Chemistry from KV1 A4 Station Pathankot, and we'll be discussing the topic measurement and scientific notation from Unit 1, some basic concepts of chemistry. Now students, you all know that chemistry is an experimental science, and an experiment, it always involves observations of phenomenon under certain set of conditions, and also the quantitative observations which we generally do, they all require measurement of one or more physical quantities. They can be mass, they can be length, density, etc. So here is the importance of measurement, which we'll be studying in this particular topic. So when we talk of measurement is a quantitative observation. First of all, you must keep in your mind, it's always a quantitative observation, and always there is a comparison to an agreed upon standard. You know that there are 7 different types of SI units. So whenever we go for measurement, there always is something, the comparison is being done to some agreed upon standards. Okay. Now every measurement, you know that it has 2 things. The first is the number and second is the unit. A measurement is incomplete without both of these. Now if we talk of the physical unit, a physical unit is defined as the reference chosen in order to measure a definite physical quantity. Okay, so every measurement has a unit. So that's the essence of measurement. Now the unit will tell us to what standard we are comparing our object, and the number, it tells us that how many multiples of the standard the object is being measured. You also know that in every measurement there is some uncertainty involved, and that uncertainty can be due to either your observer skill or it can be due to the limitation of our measuring device. Okay, sometimes what happens, the observer is not skilled, and therefore there is always an uncertainty involved in the measurement. Secondly, there may be cases in which our measuring device is not proper, it may have some errors, so that is the limitation also comes. So always keep in your mind that there is always an uncertainty which is involved in measurement. Now we can take an example wherein we are applying this idea. Now scientists have measured the average global temperature rise over the past century to be 0.6 degree centigrades. Now in this measurement, degree centigrade is telling us that the temperature is being compared. So degree centigrade means that the unit which we are using from the 7 fundamental units is the temperature one. So here comes the importance of the unit. Secondly, 0.6 tells us that the average temperature rises 0.6 times the standard unit of 1 degree Celsius. So it is being multiplied by the standard unit, that is the 1 degree centigrades. And the confidence, that is, there is always an uncertainty involved in measurement, as I told you. So the confidence in the measurement is such that we are certain the measurement is between 0.5 to 0.7, but this 0.6, you know that it can vary from suppose 0.60 to 0.699 and so on. So that's what we were just talking about, that there is, we can say, always a limitation of the measuring device as well as of the our observer. So now let's talk about scientific notation. It's a very important way of expressing small and big numbers, and this scientific notation you have been doing it from class 7th in mathematics also, and also called as exponential notation. Now we occasionally deal with big and small numbers. Okay, we commonly measure objects that are many times larger or smaller than our standard of comparison. Fine. And writing large number of zeros is, you know, a very tricky and confusing thing. Like for example, if you want to write the diameter of sun, then you can just imagine that how many zeros you have to write after this we can say number. Similarly, if you want to find out the average diameter of an atom, then also you know that so much large number of 0 has to be written before finally arriving to our destined number. So a scientific notation generally is where in which each decimal place in our number system represent a different power of 10. So you can just see that the large and the big and the small numbers have been successfully converted into scientific notation. So the representation given here is much more, we can say, in an easier terms to even write down also and to understand also. So here comes, we can say, the importance of scientific notation. So scientific notation writes the numbers so that they are easily comparable by looking at the power of 10. So what we do, we always take in scientific notation, we always take the power of 10. Now in this case, the exponential part, we can just understand the exponential part. When the exponent of 10 is positive, it means that the number is that many powers of 10 larger. Okay, so higher the, we can say, higher the positive power you are getting in this scientific notation, it means that higher will be the value of that particular measurement. Similarly, if the value which you are getting on the exponential term is negative, so it means that the number is that many powers of 10 smaller. So you can just see that in this case the power was minus 10. So it is, we can say, a very small number, and that is what actually happens. The average atom's diameter is a very small one, whereas when we look at the diameter of sun, you can just see that how, we can say, big the diameter of sun is. Fine. So scientific notation, it generally compares numbers written in scientific notation. So first we have to compare exponents on 10. Then if exponents are equal, then compare decimal number. Now generally there can be instances where comparison has to be done. For example, this is your exponential notation and these are few cases. For example, you have been given this case in which the power in this case is 5, whereas the power in this case is 2. So obviously 5 is greater than 2. So therefore this number will be, this scientific expression will be greater than this. Similarly in this case, you know that the power minus 2 is greater than power minus 5. So obviously in this case this number will be greater than this. And similarly, now when if exponents are equal, there can be instances in which the exponents are equal. Then we have to compare the decimal numbers, and the one decimal number which is higher will be the, we can say, larger one. So in this case 7.89 into 10 to the power of 10 is greater than 1.23 10 to the power of 10. So this is how comparison is done. Now let's understand that how we can write numbers in scientific notation. In this case, first of all, you have to locate the decimal point. Second point, move the decimal point to obtain a number between 1 and 10. Third, multiply the new number by 10 to the power of n, where n is the number of places you move the decimal point. And this is very important. If you move the decimal point to the left, then n is positive. If you move it to the right, then n is negative. See, students, understand this topic very carefully, because there are many instances in which we have seen that the students, they take scientific notation on a very lighter note and they commit a lot of mistakes while calculation is being done. So understand that whenever you are moving the decimal point to the left, remember always the decimal point will move, okay, not the number. So when the decimal point is moving to the left, the n will be positive, and if you are moving decimal point towards the right, then n will be negative. Okay, so let's understand. Now this is the number which has been given to you. So locate the decimal point. Decimal point will be here. See, this is the decimal point. Now move the decimal point to obtain a number between 1 and 10. Okay, this is, you know that as you move this number, now as soon as you are moving this number by 1, 2, 3, 4, that is between unit and 10, then you have to remember, you have to keep in your mind that how many positions you have moved the decimal. Okay, so in this case you have moved 1, 2, 3, 4 decimal points. So the power will be 4 since you have moved the decimal towards the left. So this is how it is being done. Now if you move the decimal point towards left, then n is positive, and if you move it towards right, then n is negative. Okay, so we can again have this number. Again you can just see this. Now in this case, since this number is less than, we can say, 0. Okay, so you are moving this decimal points towards right. So locate the decimal point, then move the decimal point. Okay, so you have moved this decimal point by 1, 2, 3 and again 4, but you have moved the decimal points towards the right, so obviously the power will be -4. So this is how it is being done. Then you can also write a number in standard form if you suppose have scientific or exponential notation. Now this is the one. If there is a power, if the power is -6, then since exponent is -6 makes the number smaller by moving the decimal places to left 6 places. Whenever there is a negative number, you will be moving the decimal towards left. Okay, it will go towards left. Okay, when you run out of digits to move around, add zeros and add a 0 in front of the decimal point for decimal number. So in this case it will be shown like this. You can write the zeros because you have to move this decimal. See, you are moving this decimal by 6 places and the answer comes out to be, we can say, it comes out to be this is written in the standard form. So this is the exponential form and this is the standard form. We can also have an example like the Indian population in 2020 was estimated to be around this much people. Now you have to express this number in scientific notation up to two decimal places. Now in this number, you know that the decimal point is present at this point. Fine. Since this number is greater than 0, so you will be moving this decimal towards left. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now let's see the answer. So it becomes 1.38 10 to the power of 9 because you have been told to express the answer in 2 decimal points. So this is how we can say we write scientific notation. Then there are few examples. You can practice this to convert the standard form into scientific notation. We have also given you the answer. You can pause the video so that you are able to solve them and then you can check your answers. Then we have also given you some practice problems in which standard form is given and you can convert it into exponential to standard form. Okay, so again we have given the answer. So I hope you have understood this concept well of measurement and exponential notation. So you can again see the video if you want to revise. So thank you.